We are at a defining inflection point in technology. While the last decade was all about cloud in smartphones connecting people, the next decade is about intelligence embedded everywhere in network, in devices, in cars, in factories, and even at the edge. To unpack what this next era looks like, I am today joined by someone who's shaping the future of technology in semiconductor, 6G, edge, physical AI, robotics, and whatnot. Dr. Durga Malladi, thank you for being with us. As you see the evolution of AI and how rapidly it's scaling up across sectors and how consumers are experiencing the benefits, how do you see the tech strategy and planning from the board and leadership perspective?
So first of all, thanks for having me here. It's the 20th edition of Mobile World Congress, and it's quite something and special in its own way. In terms of how we see the overall technology evolving, AI is now a pretty mainstream technology that's permeating every sector of the industry.
Yes.
And so when we think about it that way, last year when we entered the data center business, it kind of completed a journey which takes us all the way from devices to the data center. The dynamics and the way that the technology actually works in different domains is different. So, for instance, in edge devices, consumer devices like handsets and PCs and XR devices, these are places which are focused on inference with pretty reasonably large models going from 1 to maybe 30 billion parameter models, pretty sophisticated models. As you go a little further up in the stack, going towards industrial equipment and into automotive sector, we are in the 70 to 100 billion parameter model range. So that's a typical place where we operate on the edge with inference as being the main focus. On the other extreme, if you go into the data center, we are talking of extremely large, a trillion plus parameter models, foundational models, both training and inference, but they operate at very different power domains. Devices like smartphones, for instance, are in the sub 5 watt regime, whereas data centers, the racks are in the hundreds of kilowatts regime. And somewhere in between, we have a network which still remains largely untapped in terms of what we want to do. So the main conversation for us from Qualcomm's perspective, and I think it's resonating with the rest of the industry, is how do you tap into that, upgrade that network, and bring in a true hybrid AI model wherein we have inference that goes everywhere from the edge to the data center, not necessarily only in two domains, but across the board. And that's been a main focus for us.
So, Durga, like you're talking about connectivity, right? Like now you talked about hybrid AI. That's such a great point you made. I'm more interested in understanding the practical benefit, like the benefits the consumers will have. Like network is now more like a horizontal enabling layer. It's no longer a back-end infrastructure layer. And everything across businesses depend on the intelligence, resilience, reliability of this network. So you're talking about this hybrid AI, and I'm assuming, and if I'm correct, please let me know, like this is going to give a different kind of experience to the end user who's expecting much more and doesn't care how it is done, but what it is delivering to you.
I think that's right on point. An average consumer probably doesn't know and doesn't care that much as to how AI inference is occurring as long as they see the benefits of it. Let me give you two extreme examples of it. If you have excellent connectivity, and there's absolutely no issues. This could be in a hardcore enterprise environment. We have no problem, even today, for instance, to have a lot of that processing done somewhere close to the device, and the user wouldn't even know. Why? Because the latency is really small.
Yeah.
But at the edge of the network, and it's used to be called as mobile edge computing, but this is about more not just edge computing, but edge AI inference, not just general purpose compute. You can run very large models out there, and these are like general purpose servers in which you have AI accelerators the cards that plug in. And this is the first entry point for hybrid AI, where the action is balanced between what runs on a device and what runs at the edge. But how do you go back and forth between these two? You need a connectivity fabric that allows you to do so. And I want to talk a little bit about 6G, but I'll come back to it. You go one step further into the network, and instead of just accelerator cards, you go one step further and say, now I can build servers. And in these servers, you can run like a trillion parameter model very easily, serving the entire enterprise. In a mobile network, it could be the place where you serve a large number of consumers. And so instead of only data rates and data services, you also start bringing in AI inferencing services within the network. And when you go one step further into the data center at that point in time, now we are talking of much larger model inference, large scale inference in addition to foundational model training. Because of the fact that we have these different nodes where computing is occurring, you also need to have the right kind of protocols to make sure that you can go from one to the other without the consumer even knowing where exactly the inference is occurring. I'll give you two examples of that. So let's talk physical AI, and let's talk about some of the other low latency applications which are running at the edge. If I'm wearing glasses or I'm in physical AI, it might be that the inference needs are pretty large. You can do a good fraction of it on the device, but you might want to rely upon somewhere in the edge of the network to perform the rest of the inferencing. But you need a very low latency fabric that actually connects between these two. That's where connectivity starts playing a role. But there's also protocols as to how do you decide what runs on the device, what runs on the network, who gets to decide that, and what are the criteria based upon which you come to that decision. And these are real-time routing functions that are implemented in devices and in the network that takes us back and forth between these two. And I did mention 6G a bit, so maybe I'll explain a little bit more as to what is it that we are doing here. This is the first time that as Qualcomm we talked about 6G. While usually people think of 6G or any G transition as basics of connectivity, this time it's very different.
Or being faster.
Exactly.
Yeah.
Very different. And we put some thought and put three foundational pillars of 6G. The first one is connectivity. It's kind of business as usual, but with some new attributes because of AI. And I just mentioned that a bit in terms of glasses and physical AI, where physical AI and glasses are excellent examples where there's a lot of uplink data that's coming in. That data is used to create new models. Those models get fed back into the devices, but you need that sort of a fabric over there. But connectivity is something that one expects from 6G. The second pillar is that of wide area sensing. Imagine if the network has bird's eye view of the entire network, and using that, they're able to perform all kinds of things, ranging from detection of drones in the sky to traffic management or something that you can do near airports. New business models are coming in. But how do you do all that? You have to have a large amount of computing capability within the radios and within the network. Now, this computing capability cannot be the same thing that runs in data centers because that's liquid cooled and hundreds of kilowatts. You have to come down to 100-watt capability, and it's all air cooled.
Yeah.
So that brings me to the third part. How do you take a network of today and bring in this advanced computing capability? So what we have now is devices, connectivity between devices and the network. Within the network, we have cards, we have servers, and when you go a little bit further out from the network, you have racks and liquid cooled racks. From our perspective, this completes the picture of how hybrid AI should be. What are the role of the devices? What is the role of 6G as it comes in? Bottom line, 6G is not just another G where all you do is connectivity. There's much more in it. But mobile operators and the overall ecosystem has a role to play here to figure out what is it that they want to do. They need to put some thought into it.
Yeah.
And in some of the regions, the same network operators are also data center providers. They're actually CSPs for sovereign AI workloads.
Yeah.
So they have a twin role now of providing both compute and data as a service.
So it's like it's a journey from connectivity to intelligence, and with a lot of context around it.
That is correct.
It's going to be very complicated. And, if you were to advise a CEO or a board member how to really plan this out in next 12 to 24 months, what would that be?
I think you have to place your bets very carefully in terms of what your core strengths are. If you're already a sovereign data center provider, for instance, and you're also a network provider, it's a natural stepping stone to start thinking of the assets that go into the data center. How do you take assets from there and gradually bring them into the network as well so that the compute portion comes a little closer to the user? So that is something that a mobile network provider can do. If you are an infrastructure vendor, someone who provides software solutions that goes into the network, well, if that network already has energy efficient, high performance computing, then you have to map the existing workloads onto those processes. So you have to place your bets as to what are the right processes for that. The answer might not be the same kind of processes that you use in the data center. It could be something different. If you're a device manufacturer, we've had Smartphones have been around for about 20 years
Yeah.
now. We haven't seen fundamentally new device categories come into the market. But there is a promise here because AR glasses, as an example, and physical AI with robotics are becoming two examples where these are brand new categories,
Yeah.
to be honest. And we don't yet talk about cellular connectivity in them. But if we add that, these would become like completely new different device categories, and they will have their own evolution path, which is different from what has happened before. It doesn't negate what we've been doing in smartphones and PCs so far, but it complements that. So that's from a device ecosystem. From a silicon provider like us, we have to be everywhere. We provide the silicon and the software that goes into all of these segments. And one final note, we've talked a lot about compute, we talked about connectivity, but there's more happening in this space because when you talk data centers and when you talk devices, a third integral element is memory. The memory architecture is itself evolving. In most AI workloads, especially when you do inference, there are two stages of doing inference. There's a prefill stage and there's a decode stage. The prefill stage is dominated by computing capability. The more computational horsepower you throw, the better it is. The decode stage happens to be memory bandwidth bottleneck. Doesn't matter how much compute you throw in, you're not going to get a better decode performance. So memory architecture is evolving. Qualcomm has come out with a very new and innovative memory architecture that allows us to go there. But if you're a memory vendor, you have to start paying attention to that part and take a look at, okay, I need to evolve myself. So everyone in the ecosystem has to rethink as to where they want to be in the next 4 years. In our 6G press release that we did, we had like 58 partners in there across the board. And we put a line in the sand that the earliest commercialization starts from 2029 onwards. We have 3.5 years to 4 years to do this, but I believe we can do this. But it takes the collective, all the partners, the entire ecosystem to come together and make it happen.
This is very insightful, and you've done such comprehensive research on technology. You have like hundreds of patents in your name. If you have to summarize, what is that next era looking like in tech and semi both? How would you describe that?
You know, one thing that in tech industry, it's very hard to make forecasts which are like 5 years down the road. But I can tell you where the trend lines are today. The trend lines are very clear. Energy efficiency and high performance computing is here to stay. There is no going back on.
Yeah.
But the other part that's happening is the use case with this. What is it that the end consumer sees after all this? They hear about 6G, they hear about glasses and whatnot. I think the fundamental shift for the end consumers is of change in the user interface to the devices that they use around themselves. We've been using touch screens and using our hands all the time. But the fact remains that voice and AI is becoming the more natural user interface to all the devices around us with agentic AI that's permeating everything. So if I were to say some of the key trend lines, AI agents, they're real now. It's not like you have to wait for 3-4 years for that to happen. The UI is changing to all the devices. We'll probably find ourselves talking to our phones and PCs more often than actually using the keyboards. That's one of the things, but it needs work, needs work to be done. But in terms of the next big thing over there, the emergence of high performance computing plus the unique memory architecture, it's the holy grail of where we really want to solve the tougher problems. The connectivity portion of it is critical and sensing is critical, but you only have all of these capabilities to harness all the data that comes in, and for that you need computing.
That's great. So you've covered like from Gen AI to hybrid AI to physical AI robotics. There are immense opportunities, and it's up to the operators and across industries, the leaders, how they make the most of it, but responsibly is what you sort of like taught us. Thank you, Dr. Durga. It was lovely talking to you. And I look forward to having more conversations with you.
Thanks for having me.